All right, mathletes, here's our notes on expectations and expected value. So, if we're talking about expectations, let's say for a coin flip, so if we toss the coin 100 times, we would expect about half of them to be up heads. So, we could say we can multiply our probability by the number of trials and we get our expectations. Same thing could be applied if we were talking about rolling a dice, okay, and trying to figure out what is the probability of it being a 4. Okay, well, it's a 1 out of 6 chance. We rolled the dice 300 times. Well, we would expect it to come up 50 times. That would be our expectations. So, anytime we want to find our expectation, okay, we multiply the number of trials times the probability of that event happening. Okay, so let's look at an example here. When an archer fires at a target, there's a probability of 2/5 that he hits the bullseye. Okay. In a competition, the archer is required to fire 40 arrows, so n is equal to 40. My probability is equal to 2/5. So then my expectation, how many would I expect him to hit? Be 40 times 2/5, and this is equal to 16. Notice this is strictly just an expectation and a hypothesis. Even though on average he hits it 2 out of 5 times, it doesn't necessarily mean that it has to be 16, but we expect it to be somewhere near 16. Okay? So here we're going to talk about expected value. So it's like expectations, but it's as we're looking at values in games of chance where maybe money's involved or certain values are involved. Okay, so our expected value is equal to so the variable, okay, times its probability. Okay, so every possible value, the variable x's, okay, we take that value and we multiply the chance of getting that value by each value, that probability, okay, and then we add them all together. And that is our expected value. Okay, so let's look at an example here. So a board game uses a spinner shown below to determine how many spaces a player will move forward on each turn. The probability is 1/2 that a player moves 1. We can see that down here. Okay, since we have half of the circle, we can think of it as 2/4, which is the same thing as 1/2. Okay, and a 1/4 chance that the player moves forward 2 or 3. Where this is a fourth of a circle, and this is a fourth of a circle. Okay, what is the expected value for the number of spaces a player moves forward on a turn? All right, so first I'm going to identify my value of 1. Okay, multiply by its probability. Well, the probability of getting a 1 is 1/2. Okay, then I'm going to add it to the chance of getting a 2. Okay, so that's my x value. All right, and the probability of getting a 2 is 1/4. Okay, and then I add that, and my other outcome is getting a 3. Probability of getting a 3 is 1/4. So now that I have this, I'm going to add them all up. So 1 times 1/2, I get 1/2, plus 2 times 1/4, well, that's 2 over 1, which is 2/4, plus, that's 3 over 1, 3 times 1 is 3, 1 times 4 is 4. Okay, so since they're all These two are 4, so I'm going to get this one as a denominator of 4, so I know that that can be written as 2 fourths. So plus 2 fourths plus 3 fourths. Now that I have a common denominator, I can go ahead and add straight across the top. So I get 7 and over 4 as my common denominator. Okay, so my expected value, if I think of this as a decimal, is going to be 1.75. So that's the expected number of forward spaces that I would be able to roll. Obviously, I'm never going to get exactly 1.75 spaces because I can't necessarily move 0.75 spaces in a game. But overall, my expected value of each term is 1.75. Okay, it can be really useful in doing games of chance. So let's look at one other example here. So if you play a game in which you have a 1 in 100 chance to win, and you win $50 for one bet, calculate the expected value. Okay, so first thing I'm going to do is the value of, let's look at the value of losing. So if you're losing, you're betting that $1, so it's negative $1 that you're betting. Okay, what's the probability of you losing? The probability of you losing, remember the complement, so if it's 1 in 100 to win, the complement is 1 minus 1 out of 100, which is not winning, or we just say we lose. Okay, well, 1 minus 1 out of 100 is 99 out of 100. Okay, so we have a 99 out of 100 chance of just losing that dollar. Okay, well, my other outcome, this is the one that we always like to think of, is the probability of winning. Well, if we win, we don't necessarily win $50 because we bet $1, so we only win technically $49. Okay, well, the probability of that happening is 1 out of 100. So what is my expected value in this game? So if I simplify it, okay, I'm just going to get negative 99 over 100. Okay, plus 49 out of 100. Okay. And I see that this is going to be 50 out of 100. Okay. So, because of this, and remember that this is a negative, okay, so that equals negative 0.5. So as somebody coming into this game, we would not like this, and we wouldn't think it was a fair game, because if we are planning on betting $1, our expected value should imply that we get $1 back. But with our expected value, we get only half of our investment back on average. So somebody would be willing to make a lot of money on this game. Okay, so that's expected value. Go ahead and highlight any questions you might have and bring them to class tomorrow.